All right, so welcome to our lesson on organic chemistry, and today we're going to be looking at something called functional groups. So functional groups are basically part of an organic compound that is going to behave in a really predictable manner. So we're going to be able to react it in really predictable ways. And so when we get to organic chemistry, it's all about combining, synthesizing new and interesting chemicals. And so the functional groups are really the interesting parts of the organic molecule. So what we're going to do is we're going to use the symbol R to represent the alkyl chain of an organic molecule. So just as an example here, something called 1-propanol. And we'll learn more about what this is, but you could already sort of guess that it must have a 3-carbon change because of the prop. And because it's an alcohol, we're going to learn that that has something called a hydroxyl group or an OH group attached to it. And if I just fill in the rest of the hydrogens as we normally would, we can see that this is an example, kind of our expanded view of propanol. Now, the point we're getting at here is all these carbon-carbon bonds are really quite stable, as well as all of these carbon-hydrogen bonds are really quite stable. And so, frankly, in chemistry, if they're more stable, that means they're generally less interesting. And so what we're mostly concerned about in propanol, or 1-propanol, is this OH group on the end. So if we wanted to draw this, we could draw it a few different ways. So we could think about our the branched formation we saw. So we could have something like this. There's our propanol, but just with an OH attached to the end. And in general terms, we could just sort of write this as R with an OH. And so R just represents the chain, or the less interesting part of the molecule, and the OH, we know that it's an alcohol because of that. Of course, this R could stand for, it's a general term. So in this case, it could be propanol, but it could also be ethanol or butanol or pentanol or whatever you like. Okay, so we've got alcohols as our first functional group, and so the general formula for the alcohols is going to be R with an OH, and so some sort of carbon chain with a hydroxyl group. And a hydroxyl group is basically an OH group. That's what that means. So an oxygen with a hydrogen bound to it. So when you need to name an alcohol, we're going to follow a lot of the same rules that we saw with alkanes and alkenes and so on. So in this case, what's important is that the hydroxyl group has to be part of the parent chain. So even if it's not the longest chain, the hydroxyl group has to be part of it. And then to indicate that it's an alcohol, we're going to switch the ending from ane or ene, and we're going to add all to the end, just like we did with propanol. So in this example here, so you can see, for example, I've got my parent chain is this one right here. It's a 2-carbon chain, so I know that that's going to be some sort of F. There's no double bonds or anything, so it's an ethane. And because I've got an OH attached to it on the end here, it's an ethanol. You could, if you were being a real stickler, you could say, well, don't we have to tell you where that OH group is? And we're going to see that it's going to matter later on. So you could say, well, this would be my number 1 carbon, this would be my number 2 carbon. You could see, though, I don't have to call this 1-ethanol, because if I went and took this OH group and moved it to the other side, then that would now become my number 1 carbon. So I can just call it ethanol. Take a look at this example here. Our parent chain is going to be this one that we can see here. Now, in this case, we are going to number our carbons, and in this case, it is going to matter. I'll number from this side here, just to make this hydroxyl group the lowest number possible. 1, 2, 3, and 4. We can see that since it's a 4-carbon chain, then it is going to be a but. There's no double bonds or anything, so it's a butane, except it's got a hydroxyl group, so it's a butanol. Because the butanol is on the number 1 carbon, I'm going to call this 1-butanol. And then I just need to mention the fact that, oh, by the way, there's this branch sticking off here. And so that looks like it's a methyl group, but it's in the 3 position. So this is a 3-methyl 1-butanol. All right, last example over here, I can see my parent chain is this one. And this is sort of a combination, right? It's that I've an expanded structure as well as a kind of a backbone structure. Just don't forget that there is, of course, a carbon bonded right in that space right there. And so this is a 3-carbon chain, so it's going to be prop. There's no double bonds, so it's a propane. But there's an hydroxyl group, so it's a propanol. And then I just need to point out that in this case, the propanol is actually located in the 2 position. So this is 2-propanol. All right, let's take a look at the next functional group. So the next functional group is an alkyl halide. And so the general formula we have for that one is R, meaning just any carbon chain bonded to X. And the X in this case stands for any halogen. Now you might remember that the halogens are that group 17, kind of over on the far right, almost on the far right next to the noble gases. So fluorine, chlorine, bromine, iodine, etc. And that means any organic compound with one of those halogens just inserted into it. We're gonna name these with prefixes. And so the prefixes are as follows. For fluorine, we're gonna call it fluoro. For chlorine, chloro. For bromine, bromo. And for iodine, iodo. And so again, we're going to follow a lot of the same rules that we've seen so far, where we're going to identify our parent chain, number it off, and then give the location of the halogen in each of those cases. So we can see here, for example, here's my parent chain. Right there. It's a 5-carbon parent chain, so this is going to be a pentane. There's no double bonds or triple bonds. There's no other functional groups to worry about. And then it just comes to numbering. Now, there's probably a really specific particular rule that says whether chlorine should come before bromine or what have you. I'm not really going to drill down too far on that. You can see no matter which way we number it, either starting from the left or to the right, then it's both the 2 and the 4 carbon that I've got my functional groups on. So I'm just going to number this side. 1, 2, 3, 4, 5. And so I've got a chloro group on my number 2 carbon and a bromo group on my number 4 carbon. Now, we will name these alphabetically. So bromo will come before chloro. And so I'll call this a 4-bromo and then a 2-chloro pentane. If you take a look at this one over here, this should be something that you recognize from before. This is, it's a cyclical structure. It's actually an aromatic structure, and it's not cyclohexane. A reminder, that shape there, sometimes we draw it like this. And so that is actually that aromatic structure we learned about called benzene. So the parent chain in this case is actually a benzene. And what we've got is we've got a chlorine group that's stuck to that benzene. So this would be a chlorobenzene. Now you might say to yourself, well, don't I have to number it off? And I guess technically you could say, well, look, there's my 1, 2, 3, 4, 5, 6 carbon. If you wanted to be really picky, you could call it 1-chlorobenzene. But to be totally honest with you, I don't think we need to. I mean, if you've got 1 chlorine group, then it's obviously on the number 1 carbon. And so we can kind of skip that step. Okay, we've got 2 more types of functional groups that we're going to look at. So the next one is called an aldehyde. And aldehyde literally stands for an alcohol that we dehydrated. So we'll talk more about that later. But the basic structure of an aldehyde is going to be some carbon chain, which is then attached to a carbon, of course, with a double bonded oxygen attached to it, and then just a hydrogen on the end. So it's an organic compound that contains a carbonyl group. Now a carbonyl or carbonyl group is this double bonded oxygen, this thing right here, this double bonded oxygen that's bonded to a carbon as part of a chain. But the thing about an aldehyde is it's attached at the end of a chain. So it's only an aldehyde if it's the terminal carbon or the last carbon in the chain that has the carbonyl group attached to it. Okay, so the parent chain must, no big surprise, must contain the carbonyl group, carbonyl. And then to name the aldehyde, we remove the ane that you would normally have in your alkane name, and we replace it with al. Now this is kind of unfortunate because alcohol is different than an aldehyde, but they sometimes sound really similar. So you have to be careful about how you say them and indeed how you write them. So if you take a look at this one here, we've got a 2-carbon chain. Okay, there's my 2-carbon chain. And so a 2-carbon chain is going to be an eth. There's no double bonds, so it's an ethane. But then because there's an aldehyde group, it's an ethanal. Now, again, in this case, you could look at this and say, well, should I call this 1-ethanal? I guess you should, but frankly, you really shouldn't have to. Well, for a couple of reasons. Yeah, you would definitely call this the number 1 carbon and not the number 2 carbon. That makes sense. But there's no need to differentiate. Because an aldehyde is always on the terminal carbon, we know that it's on the number 1 carbon. There's just no doubt about that. So there's no need to specify the locations of these things. All right, let's try a little bit slightly trickier one here. I've got, now notice here that these are all carbons, but this last one here, this is a hydrogen. That's just showing me that there's no other carbon as part of the chain. This is indeed attached to the terminal carbon, or the end of the line. So my parent chain is right here. There's my parent chain. It's a 1, 2, 3, 4, 5 carbon chain, so that's a pent. If there's no double bond, so it's a pentane, but then it has an aldehyde, so it's a pentanal. Again, I'm not going to call this 1-pentanal because, well, it's definitely on the 1 carbon, but I am going to number it off. So this is my number 1, 2, 3, 4, 5 carbon, and that's important because I've got this little alkyl group that's sticking off there. And so this chloro group is stuck to my number 2 carbon, so this would be 2-chloropentanal. All right, one last group to look at, and that is something called ketones. Now, a ketone is going to look like this. It's going to have some sort of carbon chain and then attached to a carbon with a carbonyl group right there. But then there's more chain after that. And so I'm going to put a little R prime here because this carbonyl group doesn't have to be exactly in the middle of the chain. It's just somewhere along the chain. So this is going to have a carbonyl group, which is in the middle. It's attached to a carbon, which is in the middle of the chain. So when we come to naming these, the carbonyl group has to be in the parent chain. Okay, so to name a ketone, we're going to remove the E from the end of the parent chain, and we're going to replace it with -one. Okay, let's try these 3 quick examples. So the first step is to identify my parent chain, which is clearly this one right here. I then I can count off my carbons, 1, 2, 3, 4, 5. So that is a pent. There are no double bonds, so it's a pentane, but then there is a ketone, so it's a pentanone because of that carbonyl group that's in the middle of my chain, or attached to a carbon in the middle of my chain. I'm going to number it so that this gets the lowest number possible. So 1, 2, 3, 4, 5. So this pentanone must be a 2-pentanone because my my carbonyl group is on that second carbon. All right, next up here, I've got this group. Now my parent chain will be this one. It doesn't really matter. I could go this way or I could go that way. The carbon chain would be the same length. It doesn't really change anything. It's a 1, 2, 3, 4 carbon chain, so it is a bute. There's no double bond, so it's a butane, but there is a ketone, so it's a butanone. Now, I do need to give the position of that ketone. So I do need to call this 1, 2, 3, 4. I do need to call this 2-butanone so that you know where the location is. It's not like aldehydes that are always on the end. I then have a methyl group here attached to the number 3 carbon, so I would call this 3-methyl 2-butanone. All right, last example. I've got my carbon chain, which is this one here. I think it's pretty clear that I should start numbering from the left here. So 1, 2, 3, 4, 5, 6. 6 carbon chain makes it a hexane. It is a ketone, so it is a hexanone, but we're going to run into a bit of trouble here because in actual fact there are 2 ketone groups attached. There's a ketone on the 2 and there's a ketone on the 3. So if I try and call this 2,3 hexanone, well, that's a little bit unclear because I don't know why there are 2 of them. So this would actually, we have to sneak a prefix in here and we would get rid of that N because it would sound funny. And we're going to call it hexadione. So that's 2,3 hexadione because there's 2 ketone groups. Okay, that's it for functional groups, part 1.